Hey everybody, welcome on back to Straight Cut DIY. In today's episode, we're back down in the basement, and today we're going to be installing a 20 amp GFCI protected outlet in the basement right below the load center. We need a little bit more juice for our saw down here, and we're just going to wire it up, so come along. Hey everybody, we're over here at the load center. I have the front panel taken off. Now I think it should go without saying that if you are not comfortable working on electricity, please do not attempt this yourself. Contact a licensed electrician. I hereby say I'm not responsible if you decide to shock, electrocute, and or kill yourself in the process of this. Please reach out and speak to someone who knows what they're doing if you do not feel comfortable doing this. All right, you can see we're over here at the main load center coming into the house. This is a 200 amp main panel, GE brand, and we're going to be installing the 20 amp breaker into this, as well as the box, which is going to be mounted right here below it on the concrete block. So let's go ahead and get started with mounting that outlet box here. Now, for the purposes of this box, this is just a standard 4-inch square box that is, this one just happens to have the rounded corners on it. So we're going to go ahead and get this leveled and marked and get out the concrete drill and put some holes in here and tie it in with some Tapcon screws. Now I have my torpedo level on here, but I know I'm going to have some runs coming up in this panel later from the bottom, so I'm trying to make sure I've got it out of the way of where those are going to be. I might actually be inclined here to put it just a tad bit lower. Yeah, I suppose here's just as good as anywhere. Okay, that is pretty level. Let's just make sure we're plumb real quick. And I'll go with that. And then let's go ahead and just make some marks here. You don't have to go crazy with these. You don't have to have 4 screws holding this thing on the wall by any means, but we'll go ahead and mark those, and let's go grab the SDS drill and start putting the holes in the wall. And this is my SDS drill here. I got this on Amazon. I'll leave a link to it down below. As always, you know, if you click on any of the Amazon links here, I do get a small commission. It doesn't cost you anything, and it does help support the channel, so I do appreciate you checking that out. This drill here is a few years old, been featured in some other videos. It is a great, it's a great tool for a DIYer. So let's go ahead and get ourselves lined up here. All right, I think 2 holes top and bottom will be sufficient. Here we got the holes drilled in there. We're just going to be using some basic Tapcon screws here. That was a 3/16 inch hole that we drilled in there. And then these just have a hex head on them that you drive with your impact wrench. So it's pretty straightforward. Got our box. And just go ahead and get these lined up here. All right. It feels pretty solid. All right, the next step that we're going to do here is we're going to get one of our knockouts popped out in order to run our wire into the box and up to the load center above. This probably would have been easier to have done first, but there we go. So we just need to go ahead and get our 12 gauge, 12-2 Romex non-metallic sheath cable stripped out here for our outlet. Go ahead and get this outer, let's get a fresh cut there. And let's go ahead and get the outer sheath off of here. So this has got cutters for both 14-2 and 12-2. And we want to just get ourselves a good healthy amount here. And just get it, and this just pierces the, when you have it lined up, it works great. It just pierces the outer sheath of the non-metallic cable, and it leaves the conductors on the inside untouched. Apologize for the light in here. It's a little hard to see here, but yeah, no issues with that. Smooth cut. No nicks. At least I'm not seeing any. No nicks. Perfect, we're good. This tool works great though. Usually, unless you're like gorilla gripping it and at a stupid angle, then this thing works every time. Leave a link down below for that too. Let's go ahead and get the paper ripped off of here. And then let's go ahead and grab one of our connectors here. So we're going to need this here to connect into the box, essentially feeding the Romex down through it. And you gotta leave, code says you have to have a minimum of 1/4 of an inch of cable sheath actually into the box. So we'll go ahead and I add a little bit more. I usually do about a 1/2 inch or so. And then you just wanna go ahead and tighten down your screws to essentially crimp or hold rather the cable here in between the jaws on this. You don't want to go cramping down on this like gorilla gripping it, like it's to the point you're compressing and damaging the conductors inside. You can get it in there, give it a toll, you know, it's not going anywhere. Totally sufficient. So another thing that I also like to do before I get it into the box is to actually strip back some of the insulation on these. Just helps when you're not down on the floor in some awkward position. So we'll go ahead and find the hole here for the 12 gauge wire. Do about 1/2 inch-ish. And strip that off. All right, great. So we got our 3 conductors here, or 2 conductors and our ground. So let's go ahead and feed this into the box. First, let's get the retention ring off of it. You know, and you want to be neat about it too. And this is a great learning opportunity here because I didn't realize it when I knocked it out. I actually knocked out the wrong size knockout. So, take a little closer look here and you'll see what I did wrong. The knockout here is bigger than the particular adapter here. So we actually need to move it over one, and then I will need to get a fill plate to essentially cover that back up. Lesson learned there, just make sure you're paying attention to which ones you're knocking out. All right, let's try this again here. We'll feed it down through. Much better. Okay, and then let's go ahead and grab your retaining lock, slide it on up, and then this just spins right onto the bottom. If you can get it started and don't have a camera in your way. This is normally pretty straightforward to get on there. And you know, you be neat about it. Don't have things all twisted sideways if you can help it. You know, line it up. And then what I do is I just take a screwdriver, flathead, and line it up on the teeth in there and give it a little extra tap just to make sure it's, there we go. Just make sure it's not going anywhere. So we have that all in the box there. Code says you need to have a minimum of 6 inches of your conductors extending beyond the face of the box. In this case, I'd say we probably have somewhere north of 9 inches here, so perfect. That is more than sufficient. And the next thing that we want to do down here is get a grounding screw. These metal boxes have this raised area on it, and essentially the reason that it is proud of the back of the box is to allow you to screw into it. And what you use for that is a green grounding screw. Now, I don't know that this is going to focus. There we go. So it is just a simple green grounding screw that goes in there, and that is what you ground your outlet to, or whatever you're wiring up here. So let's go ahead and get a little bit of a pigtail for this so that we can attach it to our outlet. Now, typically, when you're need a pigtail for something, you just, grab a little extra off the end of your wire, snip it off, and you'll be good to go. This stuff is so expensive, and I don't have any offcuts right now that I usually have a stash of. So in that case, you can actually get yourself a spool just of ground wire. This is the 12 gauge. And you can just pull this off. This stuff is relatively cheap compared to, the cost of 50 foot of Romex. So let's go ahead and just take a little bit off of this, and we'll make our own pigtail here. Okay, so get yourself one of these grounding wire nuts. They've got a pass-through hole here in the top. And essentially that allows your grounding conductor coming out of your Romex to slide over. And then you can take your pigtail and place it inside the wire nut. And then just tighten this down. You want to do it pretty tight, but you also don't want to strip it out on the inside there, so. Okay, and then just give it a good tug. Make sure it's in there. And what we have now we have our grounding pigtail in there. We also have our main one coming from the Romex. We'll take our grounding screw and we'll start by actually fan folding this in place here. And we want to put a little bit of a hook on the end of our ground here. And these work great for doing that. Just these strippers, I really enjoy those. And let's see, what do we do with our Phillips head? There we go. And then it's important to make sure that you have your hook wrapped in a clockwise position here. And just get this started. All right, now let's go ahead and get this all tucked up in here. Go. All right, we're grounded. Now, just a matter of connecting the pigtail and our neutral and our hot up to the GFCI outlet. So the next step here is getting this receptacle actually wired up. And you'll note here, this is, as I said before, a GFCI outlet. It is a 20 amp, noted by the horizontal connector here for the prong, and it has your typical test and reset switch on it. So should this thing get a ground fault, it will trip and you have to come over and hit the reset button to reset it. The back of these is just like any other receptacle. You'll have both a silver screw for your neutral and a brass screw for your hot. Pretty straightforward to wire these up. Here's the grounding screw on the bottom. So we'll go ahead and start with the grounding screw. Now before you can actually wire up your receptacle into one of these metal face plates, essentially this just goes right over top of the front of the square box here. This face plate actually ships with, and I already broke them off, a couple of tabs that are attached to the top and to the bottom. You just have to snap those out. Don't throw them away. They have a purpose, and I will show you here why. Now with your receptacle, typically the top of this is called the yoke, has a couple of prongs or wings, if you will, that that come off of it. I just bent these and snapped them off, and there's two, the top and the bottom, and that essentially leaves you with something looking about like that. Now, if you take your cover and you put the receptacle into it, the hole that's at the top and the bottom of it is not threaded. So you're unable to actually attach the receptacle to the plate. That is why you need to hold on to the little metal tabs that you snap off of the faceplate. And essentially what those do is on the back here, if we can show this, this has got a tiny hole in it, which is exactly the right size threads for the receptacle screw that comes with the receptacle. So let me go ahead and try and get this started here. and I don't know if you can see that coming through, but there is a screw making its way on up in there. And we'll go ahead and get the one on the bottom started as well. Okay, so we now have our outlet receptacle mounted to our plate. So there you go. So let's go ahead and actually get the wires into the back side of the terminals here. So we'll go ahead and get started with our ground. Man, might have to loosen up this a little bit. That's a tight squeeze back there for that. Yeah, a little bit more. That is tight. And we now need to take our, where are we at here? Our brass screw and connect in our hot wire into that. And we'll get our neutral into, there we go, into the silver screw. So if we take a look here, you can see the neutral screw has been stripped back. It's underneath the brass plate of the terminal screw. The screw's been tightened down, securing the wire between the plate and the side of the receptacle. Same for our hot wire and for our grounding conductor as well. So now that we have all of these in here, what we're going to need to do is go ahead and tuck or fan fold our wires carefully into the box. We've got our screws removed from the faceplate, and we're just going to go ahead and get the faceplate attached here. Let's get these wires back in the box again. Okay, all mounted, wired, fastened. We just need to get the plug for the top of the box here, since I'm an idiot and punched out the wrong one. Lesson learned, don't do that, because this is probably going to be as much as the box was to get a plug for that, because I don't actually have any of that size. I got a bunch of the 3/8 inch ones, but I don't even know what size it is. Probably half inch or something. I do not have any of those. So anyhow, next thing we need to do is actually take the Romex wire and get one of the knockouts out of the bottom of the service panel and get it wired up here to our circuit. Now, again, I guess, like I said before, if you're not comfortable doing this work, do not get into your panel and start doing this by yourself. Check with an electrician, because this is still an energized panel. We have you know, 2 rails going up the back, which are energized collectively with 240 volts. So let's not be touching those. But we do have our bar here for our neutrals and our grounding conductors. Let's strip this off here. Again, make sure we're lined up with our 12-2. There we go. Sheathing has been pierced, so now we just need to strip it off. And we'll get that fed carefully up through the retaining bushing here. So I got the wire passed up through the conductor. Now we just need to tighten it down here. Now that we have that in place, next thing we need to do is actually zoom you on out here and deal with the conductors within the load center. Now, in order to get that wire up, the breaker we're going to be using, like I said, this is a 20 amp circuit. I have a 20 amp half height circuit breaker here. Now, I'm in Pennsylvania. We're still under the 2017 NEC codes, so we are still allowed to utilize non-arc fault breakers, which is great because, as you saw above here, this panel is filling up. So we're going to be probably popping out some of these full height ones and replace them with some more of the half heights. But I have a spot right here underneath this 15 amp circuit, which will allow me to get this new 20 amp half height right underneath it. So, you know, there's no right or wrong way, I guess, per se, or order to do these in. I tend to be in the camp of doing the ground and the neutral first. So when it comes to wiring these up here, you essentially have your you know, bus bars going down either side, and the neutral and ground terminal bars here. So you just connect this up. Now, some people will put, you know, all neutrals on one side or whatever. It truly doesn't matter. These holes can share both neutrals and grounds. So we're putting it on this side of the box, so that's where we're going to run our conductor. Now this is a number 2 square bit for these screws on these runs here, and then you just want to keep your wires neat and tuck everything to the back. Keep things as neat and tidy as possible. And then we're just going to repeat that same thing for our neutral wire. Typically I'd be zip tying stuff together, but I have other circuits that eventually are going to get put in here within the next couple months, so I'm going to let it go for right now. And then last but not least, it's just a matter of getting the hot wire connected here. So this time we're just gonna essentially do the same thing. We're gonna measure up how much we need. Somewhere in the neighborhood of probably like there. All right, we've got our half height breaker here. So let's go ahead and get that wired up to this. Now the way that these circuit breakers work is essentially there's a terminal screw that you just loosen and slide the wire in underneath it and clamp it down. Again, this is using a number 2 square bit drive. And I always make sure that the breaker is turned off. And then you just feed your wire. She is in, and we'll just tighten it down. All right, now that you got your breaker, moment of truth, you just need to snap it into the bus bar. My apologies, but I could not do that one-handed safely away from the camera. So that is now in there, and we'll tuck our wire again neatly out of the way. And now we have the breaker in there installed and the outlet down below. We'll go ahead and turn on the breaker, uneventful, and we'll give it a test here. So let's hit the reset. Let's reset. You can see, maybe you can see that the green pilot light has turned. Maybe you can't, it's actually too bright in here. But anyhow, green pilot light has turned on. There you go, now you can see it. Green pilot light is turned on, indicating that it's tripped. Go ahead and hit the test. It's tripped. I had that backwards, apologies. Hit test, the green pilot light goes out, hit reset. Now you know you have power. Now that we have that wired up, let's just grab our 3-prong tester and make sure that we're good. 2 amperes means we're good. They hit the top. There's a GFCI tripper on this. We'll hit this. Now you can see it just tripped it. Tripped the outlet. Hit reset. And we've got our green pilot light back on. So that's what's involved in installing a 20 amp GFCI protected outlet along with a metal box, wiring it into a 20 amp circuit into the load center, and successfully tested it out with the outlet tester. So I hope you found some good tips inside this video. Again, I'm just a DIYer here. I probably make mistakes all the time. Leave it down in the comments. Smash the like button. Let me know if this was helpful for you. And be sure to check out one of our other videos up here. And I'll see you on the next video.